So tracking server captures parameters, metrics. See, parameters are like your input. When you give different types of inputs, your results will change. Metric is the result that you're getting. Artifact means is the entire code and data, everything. Metadata is the information about what were the inputs, how many inputs were passed, when it was passed, what was the result, where is it getting recorded, right? That metadata information. And then models is basically the best model that is chosen, or the models that we are going to execute. Now, the thing is, if you look at this architecture, the architecture basically says that, okay, this is the user interface. Okay, let's say this is user interface. User server. This is the server, MLFlow server, tracking server. But for this front end UI, you need some backend. Right? So these are different layers that we will have to look at. Let me show how these things work. The MLFlow tracking server can have different setup or different design. The metadata will always be stored in SQLite database, or it can be in local directories, folders. I'll probably use folders. So either database or folders where you can dump the content. The artifacts, this is your metadata. This is the artifacts. Artifacts is nothing but your code, data, everything that is getting generated or that is being used here. This one will be always be placed in folders. Okay, so these are the two things that we basically try to say in the MLFlow tracking server. So for the metadata, either you use database or local folders. When you're running it on local, everything will be in local folders only. Don't use any SQLite. I mean, it creates, but it's automatically done basically. Don't try to push it, but you can also try and save the metadata into your local directories. By default, we will get database created, folders created, ML runs folder will be created, right? All these things will be automatically done when you're running it on local machine. You can also change the flow, right? This is basically your flow. You can see everything is in our local machine. This is local host. So everything is in single machine. If you have, let's say, a scenario where you want to use database, so you can use database here. So the difference here is the file store and local artifact repository. Both of them are folders. File store is nothing but folders. If you want to use database, then you can try and use database here for Metastore, and local artifact repository is your folders, right? So this is one, this is two. Carefully observe the difference. Here you'll have files. Both are in the same representation. Both of them are files in local folders. Here you'll have files and the database. This scenario can also be implemented in a server, different location, right? It does not need to be in our local machine. So over the HTTP, that is over internet, we will be able to work with your tracking server, right? So again, the same logic will go. Here you can see SQL database and folders. So you have a local host, and then you'll have a tracking server where you have file store, local artifacts, and the communication with respect to your UI or your code and all that. This is your code, right? This is your code. So this is happening through UI, REST API calls. The database, the folders, that is your local artifact repository, all these things can be placed in different systems. Right? So this is something, again, you can play around with. This is your architecture. Depending on what hardware resources you are using, you'll be able to play around with these settings. Okay, but yeah, these are the different things that we will be dealing with. So metadata, you can have local file system, that is file store. It will create a folder called ML runs directory. This by default it creates. You can also use SQL store. The good thing is it also supports production level database softwares as well. Predominantly SQLite is used because it is, of course, light version. We can also use the plugin schemas. It again internally tries to store. We can also have customized Metastore databases that can be figured out. If you're running it on Databricks, then it has other features also. You can also use cloud-based database services. Okay, so these are all different things that can be supported for your metadata storage. Whereas artifact store, when we speak about, it is folders basically. Right? It could be a local folder, it could be a S3 bucket or any of your cloud platform storage related things. DBFS is again the directory or file store or folder structure on Databricks. So this is Databricks file system. You can say Databricks file store. So these are nothing but folders. This is either folders or database software. Right? So that's basically your MLFlow tracking server. These are some of the examples on how we can try and store your data. But you can skip this. This is not. You can probably look at it at a later stage. Artifact store, these are all your different folders. And if you talk about Metastore, this is the abstract store. Metastore basically. It generally uses your data stores, or you can also use folders. But here it is only folders. Right? So this is basically how your MLFlow works. These are various Python APIs that we have. These are all readily available codes, you can say, which are supported by MLFlow. Naveen, you have a question?
Hey, Sharath, I had a couple of questions. Like one you mentioned about reproducibility, right?
Sorry?
So
one you have mentioned about?
Reproducibility, right? And the second,
reproducibility, yes.
So in case of non-deterministic algorithm, so is that feasible? Like we cannot get same results on multiple runs, right? So in machine learning models.
See, once you have the weights, see, non-deterministic models basically means when you are doing iterative works, it is going to give different results. But for example, neural network, once you define what is the best model, you're going to save it, right? Best model means it's nothing but you're identifying some weights. So once the weights are finalized, it is a fixed model, isn't it? It can be repeatedly used again and again. Same results will be there. But if you're saying that in the first execution and second execution, I should say, get the same results, then no, non-deterministic models will not give these same results in these multiple executions.
So how can we ensure the reproducibility there in that case?
No, what if, see, I will run neural network multiple times. I'm not getting same results. These are multiple runs. I will run 100 times, for example, 100 execution. Out of all this, which model is giving us best results? Say, for example, somewhere here, it basically says 75. 75th run is giving us the best results. Now, MLFlow is tracking all the details of these 100 executions. So when I look at the 75th run, I will know what are the results, what are the parameters which are used. I will know what is the model. That means the weights, W1, W2, W3, so on and so forth. I will use this best model for deployment. Now, this model will be fixed, right? Weights are fixed, so it will not change. I will be able to reproduce the same results if I use this model, 75th model.
Yeah, got you. Yes, Sharat.
Okay.
Yes.